So next we want to prove the relationship between the parameters of BIBD. These proofs are very important. For that, first we have to know what is incident matrix of BIBD design. Let N denotes the incidence matrix of the design BIBD. Note that Nij equal to 0 or 1 for all Ij, where I equal to 1 to V and J equal to 1 to B. It's depending upon whether the ith treatment occurs or does not occur in the jth block. So this is the incident matrix of balanced incomplete block design. So we need to prove the relationship, right? The first one, what is the first relation? VR equal to BK. So we need to prove that. Proof. So consider E1E into N E B1. What is E1E? E1V equal to 1, 1 so on, 1 of order 1 cross V is a row vector of order 1 cross V. Then N, incident matrix. That is N11, N12 so on, N1B, N21, N22 so on, N2B. Similarly, N V1, N V2 so on, NVB is an incident matrix of order V cross B. Then EB1 is a column vector 1, 1 so on, 1 of order B cross 1 of order B cross 1, which is equal to 1, 1 so on, 1 of order 1 cross V. Then we have to multiply these two matrix. Then we can get what is the result? N11 into 1 plus N12 into 1 plus so on N1B into 1, right? That is summation J N1J, right? Similarly, the next row N21 into 1 plus N22 into 1 so on N2B into 1, that is summation J N2J. Similarly, NV1 into 1 plus NV2 into 1 so on NVB into 1, which is equal to summation NVJ, right? So we know that summation J Nij equal to, what is summation J Nij? is n I dot, right, which is equal to r I. So we can write it as 1 1 so on 1 v cross 1 cross v into here summation j n 1 j, right, which is equal to what is this, is equal to n1 dot, right, is equal to r1. So here we can write it as r. Similarly, the second one, which is equal to n2 dot, is equal to r2. Here r. Similarly, we can get this, right, which is equal to v into r. Equation 1, that is e1v into n e b1 equal to v into r. Equation 1. Also e1v n e1 e b1 equal to what is e1v n e b1, similar, right, it is 1 1 1 so on 1 1 cross v incident matrix and 1 1 so on and 1b. Similarly n v1 so on and bv. Here eb1 equal to column vector, which is b cross 1. So in above case we first multiply these two, right, in here we must multiply these two vector, these two matrix, that is 1 into n 1 1 1 into n, what is that, n 2 1. Similarly 1 into n v1. What is the answer for that? Is equal to summation I n I 1, right. Similar second 1 into n 1 2 n 2 2 so on n v2. 1 into n 1 2 plus 1 into n 2 1, so 2 2 plus similarly 1 into n v2, that is equal to summation I n I 2 so on summation I n I n I b, right, n I b. Here same 1 1 b cross 1, right. Which is equal to what is summation I nij. Summation I nij is equal to n dot j, right, which is equal to kj. So in the last we written that summation I ni1 summation I ni2 so on summation I nib, right, and the column vector 1 1 1 so 1 b cross 1, right, which is equal to k k so on k into 1 1 1 1 of column vector b cross 1, which is equal to k into b, right. Equation 2, that is e1v and e b1 equal to k into b. From 1 and 2 LHS are same, hence RHS must be same. which implies RV equal to KB. Hence, proof. Then we go for the second relation. What is second relation? Is R into K minus 1 equal to lambda into V minus 1. And the proof is, so for that, for this relation, we should consider n into n transpose matrix. We have n into n transpose. Here n is of order. What is order? B cross B and B cross V, which is equal to n11, n12, so on, n1b, n21, n22, so on, n2b, n so on, n v1, n v2, so on, n bv. Right? What is n transpose? n11, n21, so on, n v1, then n12, similarly n1b, n22, similarly nv2, n2b, similarly here nvb, right, which is equal to r lambda, so on, lambda, then lambda r, so on, lambda, 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 so on, r of order v cross v. That is n transpose equal to r minus lambda iv plus lambda ev. We can write this matrix as r minus lambda iv plus lambda e v cross v. That is the ijth element. That is the ijth element of n transpose equal to summation L equal to 1 to B NIL NLJ, which is equal to R if I equal to J, lambda if I is not equal to J. This is the element of n transpose matrix. Since in the above summation is the pair of Nij which both are 1 1 for all j equal to 1 to k. Then consider n transpose E1, n transpose E1, which equal to, what is n transpose? N transpose equal to r lambda, so on, lambda lambda r so on lambda. Similarly, lambda lambda so on r, right? And e v1 equal to, that is a column vector of order v cross 1, right? Which is equal to, what is this matrix? N transpose is equal to r minus a lambda iv plus e vv plus lambda evv, right? Plus lambda evv. And here this is e1v, right? It is equal to r minus lambda, we multiply by ev1 is equal to ev1 into iv equal to ev1 plus lambda, here evv, right? We can write it as v, then ev1, which is equal to lambda ev1, sorry, r ev1 r ev1 minus lambda ev1 plus lambda v ev1, which is equal to we can write this as r ev1 plus this term lambda v ev1 minus lambda ev1. Then take common term outside, that is r plus lambda v minus 1, this lambda common term, right? You can take outside, then v minus 1 into e v1 for the whole term, right? Equation 1. Then similarly take n transpose e v1 equal to, what is n? Then take n transpose value, that is n11 so on n v1, n12 so on n v2, similarly n1b so on n vb, right? Then v1 equal to 1 1 so on 1 of order v cross 1, right? Which is equal to n into what is last term, n11 n21 so on n v1, right? This is a n transpose matrix, n12 so on n1b, n22 so on nv2, similarly n2b so on nvb, right? And the ev1, that is 1 1 so on 1 of order v cross 1. Then multiply these two terms. What is that? n11 into 1 plus n21 into 1 so on plus nv1 into 1, that is summation I ni1, the second row. Similarly we can get summation I ni2, similarly so on summation I niv. What is summation I ni1? It is n dot 1, right? It is equal to k1. Here we can write n into k, and the second one n dot 2, right? That is k2. Similarly, n dot v is equal to kv. You can write it as k here. So k. Then what is n? It's an incident matrix, right? Then write capital N equal to n11, n12, so on, n1b, n21, n22, so on, n2b, similarly here, nv1, nv2, so on, and bb into this k, k, so on, k, right? Then multiply these two matrix, k into, sorry, n11 into k plus n12 into k, so on, plus n1b into k, right? So we can take k outside. In all row is multiplied by k, right? So we can take k outside. Then here these summations are remaining, right? This summation j and 1j for the first row, right? In the second row, and j summation j and 2j. Similarly, summation j n and vj, right? What is summation j and 1j? It's equal to n 1 dot, right? That is equal to r1, right? Here n 2 dot is equal to r2. Similarly, here n v dot is equal to rv, right? You can write it as k into r, so on, r, right? We can write it as k into r e v1. Here k, right? Then this r term, r of r is a column vector. This is a column vector of element r of order v cross 1, right? So we can write it as these matrix as r into v1. Equation 2. Then comparing 1 and 2, then comparing 1 and 2, LHS are same. Hence, RHS must be same, right? For the first equation, what is RHS? That is, for the first one, R plus lambda V minus 1 into EV1, right? Is equal to, second RHS is K R EV1. Which implies, here we can cut this term, right? Then we can write R plus lambda V minus 1 equal to K minus R. We can write R plus lambda V minus 1 equal to KR, which is equal to here we take R this side, then we can write, so we can write KR this side, right? KR equal to R plus lambda V minus 1, which implies KR. Then we can take R this side. This minus R is equal to lambda V minus 1, which implies R K minus 1 equal to lambda V minus 1. Hence, the second relationship is proved, right? The third one,